Welcome back, everyone. We're going to be solving LeetCode 367, valid perfect square. So we're given a positive integer num, and we want to return true if num is a perfect square or false otherwise. And they define a perfect square as an integer that is the square of an integer. In other words, it is the product of some integer with itself. And they say that we cannot use any built-in library functions such as the square root function. So obviously, if we're given the input 16, we want to return true because 4 times 4 is equal to 16. So we're going to solve this with binary search, which is going to give us an O of log n runtime, and we will do this with a constant space. So how can we solve this with binary search? Well, let's write out our binary search template. We'll say left is equal to 0, right will be equal to our number initially, and while left is less than or equal to our right pointer, we are going to run our algorithm. So binary search, we always need to find a midpoint. So if left is at 0, r is at, say our input is 16, r will be 16. We are going to run binary search until we find the midpoint from 0 to 16. All right, this midpoint is going to be left plus right minus left divided by 2, again, avoiding integer overflow. That's why we do it like this. Now, we need to say if m times m, right, the midpoint times itself, if that is equal to our given input number, then we can just return true. But if m times m is less than our given input number, what does that mean? That means we need to now move our left pointer to the midpoint plus 1. Else, if our midpoint times itself is greater than our number, then we need to move our right pointer 1 below the midpoint. So mid minus 1. And if we ever exit this while loop, that means we never found a perfect square. So we can just return false. So we'll run this, and it does pass both test cases. We'll submit, and it does pass. So, and like I said, this was binary search, so it's going to be O of log n for time and space complexity, no extra data structures, so it is going to run in O of 1 space.